Hello everyone, welcome back to the channel. In today's video, we're going to learn about honeypots and see how to create one using a free open source tool called PentBox. So what is a honeypot? A honeypot is a fake or decoy system that is designed to attract attackers. Instead of protecting a real server, it pretends to be a vulnerable service and records every connection or attack attempt. This helps security teams detect suspicious activity, understand attacker behavior, and collect valuable threat intelligence without putting real systems at risk. In this video, I'll explain the basic concept of honeypots and then demonstrate how to create one using PentBox in Kali Linux. So let's get started. Before starting the demo, let's look at the tool we'll be using. This is the PentBox GitHub repository. PentBox is an open-source security toolkit written in Ruby. It provides multiple security-related utilities such as cryptography tools, network tools, web utilities, IP grabbing, geolocation, and one of its most popular features, a lightweight network honeypot. Let's look at some of the key features of PentBox. Attacker IP and port display *. The honeypot now automatically shows the attacker's IP address and source port, making it easier to identify where connections are coming from. DoS testing modules *. PentBox includes several legacy DoS proof-of-concept modules for testing older vulnerable systems in controlled lab environments. First, open Oracle VirtualBox. Start the Kali Linux virtual machine. Once Kali has booted successfully, open the terminal. Switch to the root user. sudo su. Now we'll download the PentBox repository from GitHub. Copy the repo URL and use git clone to download the rep. Git clone may take time based on the internet speed. After cloning is complete, navigate into the downloaded directory. And use ls command to list down all the files. We can see a zip file. We need to unzip the file. Now copy the unzip command from the GitHub page and paste in the terminal to unzip the file. We can see the files is unzipped. Now we will add execution permissions to folder using chmod command. Now move to folder path using seed command. Now copy and paste the execution command from GitHub and start the tool. The PentBox main menu is now displayed. Now let's explore the main menu options available in PentBox. Cryptography tools provide basic encryption and encoding utilities. These can be used to encrypt text, generate hashes, or perform simple cryptographic operations for learning and testing. Network tools * include utilities for network-related security tasks, such as scanning, connectivity testing, and analyzing network services during security assessments. Web utilities * are designed for web application testing. They include modules like HTTP directory brute forcing and common file discovery to help identify hidden resources or misconfigured web servers. IP grabber * is used to capture the IP address of users through specially crafted links or requests. This feature should only be used in authorized environments for security testing and awareness. IP geolocation * attempts to determine the approximate geographic location and related information for a public IP address, helping analysts understand where a connection may originate. Mass attack * contains modules that automate repetitive security testing tasks against multiple targets. These features are intended for authorized penetration testing in controlled environments. License information asterisk displays the software's licensing terms, usage rights and credits to the developers. Finally, asterisk exit simply closes the PentBox application safely. Overall, PentBox organizes its features into these categories, making it easy for beginners and security professionals to access tools for cryptography, networking, web testing, reconnaissance, and security research from a single interface. Since our goal is to create a honeypot, we'll select Network Tools by entering Option 2. Next, let's look at the options available under the Network Tools menu in PentBox. Let's open the Honeypot option. After selecting Honeypot, PentBox displays two configuration options. The first option is Fast Auto Configuration. The second option is Manual Configuration, which provides advanced customization. We'll first demonstrate the fast configuration. Select Option 1. The Honeypot is now running successfully. It is listening on the system's IP address. Now let's find our Kali machine's IP address. Open another terminal and use ifconfig command to check the IP address of the machine. Copy the IP address. Now open a web browser. In the browser's address bar, enter the Kali machine's IP address. We can see that access denied is displayed. Switch back to the Honeypot terminal. Notice that PentBox immediately captures the incoming connection. Even though this wasn't a real attack, the Honeypot successfully detected and logged the network activity. This is the HTTP request captured by the PentBox Honeypot when a client connects to it. The first line, get/http11, shows that the client is requesting the website's home page. The host header contains the target server's IP address, while the user agent identifies the client's browser and operating system, in this case Firefox running on Linux. Other headers such as accept language, and accept encoding tell the server what content types, languages, and compression methods the client supports. Finally, the connection and upgrade and secure request headers specify how the connection should be handled. Now let's see how to customize the Honeypot. Stop the current Honeypot. Open the Honeypot module again. This time select Manual Configuration. Manual mode allows us to customize several settings. First, it asks which port the Honeypot should listen on. I'll use port 23, which is commonly associated with the Telnet service. Next, PentBox asks for a message to display whenever someone connects. Next, it asks whether we want to save the logs. Select Yes. For the remaining options, we'll keep the default settings. The customized Honeypot is now running. Now let's simulate an attacker. Open another terminal window. Use Telnet to connect to our Honeypot. The Telnet client receives the message we configured. Now switch back to the Honeypot terminal. We can clearly see that PentBox has captured the connection attempt. This is how a simple Honeypot works. Instead of protecting a real service directly, it creates a fake service that attracts attackers and records their activities. Security teams use honeypots to detect unauthorized access attempts, study attacker techniques, collect threat intelligence, and improve their overall security posture. PentBox is a great tool for understanding the basic concepts of honeypots. However, in production environments, organizations typically use more advanced honeypot solutions such as Cowrie, Teapot, OpenCanary, or Diania, which provide richer logging, support multiple protocols, and integrate with SIEM platforms. I hope this demonstration helped you understand how honeypots work. If you found this video useful, don't forget to like, share, and subscribe to the channel for more cybersecurity tutorials. Thank you for watching, and I'll see you in the next video.